In this lecture, we'll create our very own ROS publisher node. We'll make a simple publisher that publishes a string that says hello world, followed by a number which increments up every time we publish. Then in a future lecture, we'll create a subscriber to receive the messages we publish. For now, let's open our code editor. And I'm going to go ahead and hit File, Open Folder. And I'm going to open up my ROS2 CPP workspace folder. It's going to ask you, do you trust the authors? You're going to say yes. And you might get these notifications saying it's scanning for kits. We're going to configure this in a future lecture. So for now, you can just say not now. You can go ahead and say don't show again. And for now, I'll just say let's not configure this project in this workspace. As I mentioned, we're going to set this up a little bit later. For now, I'm going to go into the source directory. And you can see it takes us into our Udemy ROS2 package. And I'm going to go into that source directory. So that currently has no files right now. So right click on it, hit new file. And I'm just going to call this publisher.cpp. Just to preface, all ROS2 C++ functionality is documented in the API documentation. There you can review specific functionality of the ROS2 library. So feel free to use this as a reference as we're coding along. In order to use ROS2 features in our C++ code, we need to include the ROS client library module. This is abbreviated as RCL-CPP, so we'll be importing the header file for it. Now, you may end up with a red squiggly line under your include statement saying that VS Code was unable to resolve this dependency since it does not know where to find it. Luckily for us, we have the ROS extension installed, so a lot of our file sourcing is handled for us. But in case you were ever wondering where these ROS source file locations are, they will be part of our installation. So if I open up a file explorer, I can go to other locations. I'll head over to my computer, and it will be in opt ROS, the name of our distribution, which is Humble. And most of the header files will be in this include section, and it is separated by package. So if I scroll down, we can actually see the RCL CPP package. So if I click on that, we see RCL CPP. And here we see all of the header files related to the ROS client libraries for C++. And specifically, we see our RCL CPP.hpp file, which we just imported in. So in case you were ever wondering where these files were located, that way you can configure any type of IDE or code editor you are using if you are not using VS Code. So here we see the squiggly line under our include statement. It's saying it can't be found. And so there are two ways which we can address this. If I go ahead and hit F1, here we see some of our commands that we can do in VS Code. If I type in ROS, there's actually an update C++ properties action that you can do, which will automatically update all your C++ paths. Instead of doing that, I'm going to show you how to do it manually so you're aware of how this works. So if I actually go over, it'll give me this little light bulb icon. So here it actually gives us a suggestion to add to include path our opt ROS humble include and then our RCL CPP, which is the location of where this file is located. So you could actually do that. I'll just head over to edit include path settings. Now, if you're ever wondering where this is, now this is the UI version of it, but all this is handled in this .vscode folder, and you will see a cpp_properties.json file. So these two are the same exact thing, but I like using the user interface rather than editing the raw JSON just to make sure I don't do anything wrong. So if I go ahead and scroll down, we see this section here called include path, and here's where we can include our header files. Now, so for right now, there actually is one included since we have the ROS extension installed, and that says go into opt ROS humble and include all the header files in this include directory, and the double star just means to recursively search throughout that directory to find the proper files. So we're actually already set up. I'm actually not sure why it's confused, so I'll actually go ahead and close this. If I hit save, I wonder if it'll fix itself. And there we go, it actually fixed itself. So sometimes IntelliSense, when it does the recursive search, it misses those files that are necessary, but in this case, when I saved, it reran the IntelliSense checker to check for where my files are located. So again, if you ever need to access that, you can either hit F1 and type in C++, and it'll be edit configurations UI. So you could just go ahead and type in C++ UI and click on that. You'll be taken back to this menu, or you could go down over here where it actually says ROS right now because our extension modified this. Sometimes it'll say just Linux or your operating system. And if you go ahead and click on that, It'll give you the same options here. It'll say edit configurations UI or JSON, so it takes you to the same page. All right, with that introduction out of the way, the first thing you need in a C++ file is to create your main function, so I'll go ahead and do that now. All right, so nothing too fancy, just creating our int main function and returning 0. Now in C++, it is standard to use 2 spaces when typing in our code. So my VS Code is actually set for 4. So if I go down over here to select indentation, we see it says spaces 4. So there's 2 ways you can configure it. You can either use spaces or tabs. It's completely up to you, but you can simply select one. So in this case, I'll use tabs, and then you can select the size. So in this case, we should be using 2 for C++, and I can go ahead and fix this accordingly. So now it has a tab size of 2, which is more common in C++ development. Great. Now let's make our ROS publisher node. The ROS2 client library is designed in a way to encourage object-oriented programming. So usually when creating a new ROS2 node, you will create a class that will hold all the functionality related to that node's operation. So let's create a class called Hello World Pub Node above our main function. Now we are going to have this class we just made inherit the functionality from the ROS client library's node object. We show inheritance by using a single colon after we declare our class, and then we will inherit the public attributes of the RCL CPP's node. Great, now let's create our constructor for this class. So I will create our public access specifier and retype the name of the class, and for now this will take in no arguments. Now, I still need to initialize the node class which got inherited. This will take in the node name that will be displayed on ROS. So I will just call it Hello World Pub Node. Notice here I use snake case for the node name, where I keep all the letters lowercase and separate words with underscores. This is the naming convention to follow whenever you're naming things which will be broadcasted in ROS. So things like topic or parameter names, which we will learn about in a bit, also must be snake case. Now, how did I know this node object takes in this node name? Well, because if I check the ROS client library's C++ documentation, it says so. Or we can even see it in our VS Code editor. If I type in our node class, VS Code will actually show all the arguments once I type in my parentheses. So if I go ahead and delete that for right now, and I remake my parentheses, we actually see a little window pop up in VS Code, which tells us some of the possible arguments we can include. So if I click on the down arrow on my keyboard, we are taken to a second constructor declaration. So here we see this one takes in a string argument called node name and has a default value for the node options argument. And then the third constructor shows the same thing, but with an extra namespace argument, which we will learn about later. So I'll go ahead and put this back to the way it was. So with those explanations out of the way, let's go ahead and create our publisher within this class. So if I head over to the ROS documentation page, the second section is labeled Publisher. Now we can see there is a function within our node class called createPublisher, and we see the declaration for the actual publisher class instance. So I'll just right click on them to open in a new tab. Heading over to the publisher object page, we see to initialize it, we need to specify a message and an allocator. Now, if you're not familiar with this format, essentially the publisher object acts as what is called a generic in C++. You can then cast these type parameters, which will affect how the generic gets initialized. So a message is a ROS interface type, which we will learn more about in future lectures. But for this Hello World publisher we are making, we want the message type to be a string that says Hello World followed by a number. Then for the allocator, we will just not specify one, which we'll call the default heap allocator. For the most part, you won't need to worry about allocators, but if you want more information, you can check out the ROS tutorial pages on creating custom allocators. And then if I scroll down, we can actually see the constructor for the publisher class. So let's go ahead and see what this would look like in our publisher node code. So I'll go ahead and reformat this. And I will create a private access specifier to our class. Then I will declare our publisher object by calling the ROS client library publisher object. Then we will need to specify the message type. To do that, I will import the standard messages ROS package, which has a message subdirectory, which will have the string message header declaration. Now again, don't worry about this too much. We will cover it in greater detail in a future lecture, but now I can specify my string publisher message like so. Now, we technically could leave our publisher like this, but it is a common practice to instead get a shared pointer of these ROS objects. There's a couple reasons for this, but it will mainly help us pass this instance to other members. Then I will call this variable publisher, and since we are in the private scope, you will generally see C++ developers add a trailing underscore to the variable to specify it as a private member variable. Now let's head back to the ROS documentation page, and I'll go over to the Create Publisher tab, which we opened earlier. Here we see it takes in 3 arguments: the topic name, QoS, and options, which has the default value. QoS stands for quality of service. If you used ROS 1 before, you can think of this as similar to the message queue attributes of publishers. You can read about the concepts of QoS at the following ROS documentation page. But for now, let's go ahead and implement this function in our C++ code. Now, I need to reference it from the node instance, so I will call this in the public section after our node initialization. So I will call our publisher variable and set it equal to this, followed by the arrow operator, which allows us access through a pointer, and calls the create publisher method. Then we specify the message type, which is the same string message type we used earlier, so I can just copy that from below. Then lastly, put in the arguments we mentioned earlier. So for the topic name, I will call it hello world, and then I can create a QoS object and pass it in 10. This just means the publisher will have a history depth of 10 messages. Should the publisher be unable to publish fast enough, it will keep up to the last 10 unpublished messages. Now, for our simple publisher, this is overkill, but for now, I will just leave it as is. Alright, that was a lot of explaining of ROS functionality just to get this code we have so far. So don't worry if this feels a bit overwhelming, as at the end of the lecture, we will review some of these concepts we just went over. But now that we have our publisher, let's have it publish messages every second or so. Now, if you've used ROS 1 before, you're probably thinking we can use the ROS rate object, which we can then spin within a for loop. And that is a viable route to go. But ROS 2 introduces timers, which can do that without the need of for loops. So we can create a timer using the timer base object from the ROS client library and use a shared pointer. Then I will initialize this object above using the node's createWallTimer method. If you have any questions about this, you can check out the documentation, but I will just try to go through this quickly. Now, notice in this little VS Code window, it is telling me the first argument is the duration, which should be of type chronoduration. So we will need to import the chrono C++ module. And I'm not sure why we're still getting this underlined squiggly for our standard messages import. I'll try and save the package and see if that fixes that. Now we just need to finish our declaration for createWallTimer. So now I can specify a duration. For example, I can set this timer to publish once every second like so. You could also specify your duration in milliseconds or some other duration data type if you wanted. It's worth noting you will commonly see people use the chronoliteral namespace so that they can use spatial shorthand notation for durations. Now I can specify 1 second by deleting this and simply typing in 1s. Now, this is completely personal preference on if you want to use namespaces or if you want it to be clear where certain data types are derived from. Then the second argument is a callback function. Well, we haven't made any functions yet, but essentially we want this timer to publish hello world every second. So let's make a new method within our class which does that. So I'll head over to my private scope. I'll say void publish hello world. Now, we will fill out this callback function in a second, but first let's finish our timer declaration. Now, unfortunately, we can't just type the name of our method callback function here. Instead, we will have to bind it as a method of our class, so this timer knows how to execute this function. So in order to do this, I will need to import the functional standard library. And I can go back to my createWallTimer function, and I'll create a second argument on another line. I'll say standard bind. And then we will put in the address of our class, and we will call the publish hello world function, which we just created, and pass it in this. Oh, and I forgot a semicolon over here. So feel free to space things out as you want to so that you can easily read it. This should be fine. So great, we initialized our timer. Now let's work on this callback function. Here we are going to want to call the publish method of our publisher, which will look something like this. Alright, so now we have to declare this message, which, as we mentioned, should be of type string from the standard messages we imported. So we can initialize it like so. Now we need to load this in with the actual string data we want the message to include. In this case, it will be hello world. Now we also wanted to include a number. So we need to have a counter variable, which we can increment higher every time we run this callback function. So let's go ahead and create a size t variable called counter down below. So now I can go back to where we load in our message and cast our counter to a string to add it to our hello world message. Then once we are done running this callback, we can increment the counter by 1. Oh, and I made a typo here. It's to string. And I forgot my semicolon after our publish call. Great, so let's quickly review what's going on in this code so far. We created a class called Hello World Pub Node, which inherited the functionality of the node object from the ROS client library. We initialized our node, created a publisher which publishes string messages over the topic Hello World. We then created a timer which will run our publish Hello World method once every second. Within our publish Hello World method, we create a string message, load our Hello World string data into the message, and then tell our publisher to publish this message. Okay, with all of this done, it is time to put this class to use by implementing it in our main function. Before we can use any ROS functionality, we need to initialize the ROS client library, which will initialize our ROS DDS communications. We can do this by calling the init function of our ROS client library module. This takes in argc and argv so that we can pass in arguments from the command line interface to configure our ROS instance. So I will need to include that as arguments to my main function and then call it like so. Then we will create our Hello World Pub Node instance within the ROS client library spin function. This function helps manage all the asynchronous functionality of our ROS node and keeps the node running until we stop it. So we will initialize an instance of it as a shared pointer like so. Then last but not least, before we exit this program, we can call shutdown to ensure our ROS instance is terminated successfully. Oh, and it seems I missed this typo right here where I forgot a second colon. So I'll go ahead and fix that. And I will scroll up to see if I made any other typos along the way. And it seems I forgot another double colon here as well. Alright, with that, we now have all the C++ code we need to create a ROS2 publisher node, which publishes Hello World once per second. Be sure to save the file either by hitting File Save or by hitting the Ctrl+S shortcut key on your keyboard. Now, we covered a lot in this lecture, so we'll go ahead and stop here. In the next lecture, we'll go over how we will be compiling this C++ code. But for now, let's review what we just learned. Alright, so in this lecture, we created a publisher node in C++. Now, the first thing we had to do was include our ROS client library C++ API. So we did that by including the header files for RCL CPP, as well as including the message type we planned to use with our publisher, which in this case was a string. And as I mentioned before, we'll talk a little bit more about these message types in a future lecture. Then we saw how we could inherit functionality from the ROS client library's node class. So this allowed us to do things such as create our node within our own custom C++ class, and when we initialized it, we would specify the name of the node and then have all of our functionality which we want for this node inside the class. So then we actually went ahead and created our publisher instance. So we did this by utilizing the message type we imported in earlier, and then calling our node's createPublish method, in which we are able to specify our topic name and quality of service settings. Don't have to worry about this too much now. For now, we just did a queue size of 10 to initialize our quality of service object. Then we went ahead, initialized our message, passed in information into that message.data attribute, and then published it using our publisher variable from earlier. And for the purposes of this node, we created a timer instance so that our publisher would publish this information once every second. We did this with the createWallTimer method of our node object, and reference our callback function, which goes ahead and runs the code from before for publishing our message. Last but not least, we went ahead and ran our node in the main function by initializing our ROS client libraries, spinning our node class, and last but not least, when we get a shutdown message, like from hitting Ctrl+C in terminal, we tell our ROS client library communications to go ahead and shut down and return 0. In the upcoming lecture, we're going to go ahead and compile our C++ publisher code so that we can execute it and utilize our ROS functionality. So I'll see you there.